Welcome to IP Experts CIPT1 Class on Demand. I'm Vic Marley, your instructor. I hold a CCIE in the voice track as well as a CCVP certification. Let's start with Module 1, getting started with Call Manager, and specifically let's take a look at the IP telephony components. This slide shows the 4 standard layers of the Cisco architecture for voice, video and integrated data. Starting with the infrastructure layer, this contains our voice over IP gateways that are used to connect from the IP network to the PSTN. It contains our catalyst switches that provide inline power and campus quality of service for our IP phones. It also contains our routers. The call processing layer. The key point here is it's physically independent from the infrastructure layer. A call manager, which resides in a call processing layer that resides in San Jose, can control bearer channels and IP phones in New York, for example. Our applications layer. Applications are physically independent from the call processing and infrastructure layers. That is, they may reside anywhere in the network. The client layer. This brings applications to the user, whether the end device is a Cisco IP phone or a PC running IP softphone or communicator, or a PC delivering converged messaging. IP communications defines 6 primary components. IP telephony solutions deliver the high quality IP voice and integrate with existing networks such as the PSTN. Unified communications combines personal productivity management tools such as unified messaging, rules-based call routing and speech recognition. Media conferencing. This allows the call flexibility by connecting people in different locations and time zones with Cisco's conferencing suite of products. This could be audio-only conferencing or video conferencing. Video telephony has been developed for enterprises and service providers who want a reliable, easy to manage, cost-effective network infrastructure for video conferencing and point-to-point video. Customer contact. Contact center solutions combine services such as intelligent contact routing and management, real-time web collaboration, and email response management, and integrate with Cisco IP telephony solutions. Third-party applications also exist. Because Cisco IP telephony products are built on an open platform, this allows for third parties to develop their own applications. IP telephony refers to the technology for transmitting voice communications over a data IP network. Call Manager. This is the heart of the IP telephony system. It is a software-based call processing agent. Call Manager software extends enterprise telephony features and capabilities to packet telephony network devices such as IP phones and media processing devices, as well as the gateways and applications. Additional services such as unified messaging and multimedia conferencing and collaborative contact centers interact with IP telephony through Call Manager Open Telephony Application Programming Interface, or TAPIs. Infrastructure. This includes the routers and LAN switches that I mentioned before and are necessary to support Call Manager clusters, providing connectivity for IP phones and gateways to the PSTN. Gateways also contain digital signal processor farms to support hardware conferencing and transcoding. Endpoints. By endpoints we mainly refer to Cisco IP phones, but now with Call Manager 4 introduced, we now have the option for video endpoints. These can be either video phones or software running on the PC that is associated with a Cisco IP phone. Application software, which is physically independent from call processing and voice processing infrastructure, include Contact Center, Cisco IPCC, Cisco Personal Assistant, Meeting Place, IVR, and video applications such as VT Advantage. QoS is also a very important part of IP telephony, which we talk about in another class. Security is a vital element now that runs on top of the network infrastructure. Network management tools are also important to help administrators troubleshoot and manage their networks efficiently. For the most part in this class, we're going to be focusing on Call Manager version 4.13. I'll also make reference to older versions of Call Manager. The primary functions of Call Manager are call processing, basic call setup and teardown, signaling and device control. IP phones register to Call Manager. Call Manager creates a database of IP phones with their IP address and MAC addresses. Dial plan administration, extremely important part of Call Manager. When users dial numbers, where do we send the call to? Which gateway? Because we can have phones in geographically diverse areas, we need to route calls based on where they're calling from and to whom they are calling. To provide not only our traditional supplementary services, but our new generation of features is also an important part of Call Manager. Directory services. Most of the advanced services that we provide to users is associated with users and not devices. For this reason, having a directory is extremely important on Call Manager. And Call Manager has an inbuilt directory called Data Connection Directory or DC directory. It does support integration with third-party directories such as Microsoft Active Directory, Netscape, Novell, and the list goes on. Call Manager does support LDAP to integrate with these directories. As mentioned before, it has a TAPI interface to allow for third-party application development. I talked about call setup and call teardown. The protocol that's used to do this is called SCCP or SCCP, Skinny Client Control Protocol. When phone A calls phone B, he dials his extension number. There's a Skinny message sent up to Call Manager. Skinny operates on TCP port 2000. Call Manager will resolve the extension number to an IP address. It then sends a Skinny message down to the destination. Assuming he's idle, he's on hook, he's ready to accept the call, Call Manager will instruct phone B to ring and will send ring back to phone A. Once party B goes off hook, the call is connected. Call Manager's involvement in the call is over at this stage, and parties A and B communicate directly with each other for the first time using the Real-Time Transport Protocol or RTP, which runs on UDP. When the call completes, when one party hangs up, a Skinny handshake takes place and Call Manager clears the resources or tears down the resources. During the call, Call Manager can also perform some maintenance functions. This is a brief look at the Call Manager administration interface, https:// the IP address of the Call Manager /CCM admin. We talked about legacy PBX technology in the C-Voice class. Hopefully you're familiar with this. If not, refer back to the start of the C-Voice class. IPT technology performs everything the PBX does and then some. Everything is distributed, whereas the PBX, everything's housed in one cabinet. You may have redundancy within, but ultimately it's still housed in one cabinet. With Call Manager, all the components are distributed, thus giving you the obvious advantage of geographical resilience. I'll let you browse through this list of why you would use IP telephony. When you purchase Call Manager, you don't need to purchase each of these individual components separately. It's all bundled in together. Call Manager 4 sits on Windows 2000, Microsoft SQL Server not 200, 2000. It contains Daily Connection Directory, DC Directory, and you should install the bars tool for backup and restore. You should do a backup on a daily basis and store tapes off-site at regular intervals. Here is a list of servers that you can use. We're going to mainly concentrate on the 7835 and MCS 7845. The hardware platforms Call Manager runs on are called the MCS servers. Because voice networks should maintain an uptime of 99.999%, the infamous 5 nines, you must install Call Manager on a server that meets Cisco configuration standards. For this reason, Cisco has collaborated with 2 server hardware manufacturers, HP and IBM, to create Cisco Media Convergence servers. HP and IBM designed these server hardware platforms specifically for Cisco voice applications. All the servers are rack mountable. Cisco designed the MCS for local setup, rack mounting and remote administration. We're going to look at mainly the 7815, 25, 35s and 45s. The 7845 is a dual processor, hence it's a lot more expensive than the other ones. The 7815 has 512 meg memory, it's a Pentium 4 chip, 40 gig hard disk. The 7825 is a P4 chip, 1 gig memory, 40 gig hard disk. There is an 80 gig hard disk option. The 7835 is a Prestonia Xeon 3060 MHz chip, 1 gig memory and 2x36 gig SCSI. The 7845 is dual Xeon, 4 gig memory, 4x72 gig SCSI, so clearly the most scalable. The table shown here lists the types of devices that can register to Call Manager. Each device that registers to Call Manager uses the resources of the Call Manager server. Each device is assigned a device weight. A device weight is a standardized measure of the load that a device is expected to put on the Call Manager server. So when you're scaling your Call Managers, you use this device weight table. Device weights are used to calculate the number of servers that are needed based on the design Call Manager configuration. They're ranked according to a measurement that is known as busy hour call attempts, BHCA. This represents the number of call attempts made during the busiest hour of the day. So you can have the same device, one in a very quiet location, which is rarely used, and one in a very busy high traffic area. Guess which one puts the most load on the server? So it's not just the device alone that counts, it's how busy that device is. Take for example here, the Skinny client. Assuming that we're in a very quiet location, he's only going to be receiving less than 6 calls in the busiest hour of the day. His device weight is 1. Compare that with Softphone, CTI port. His device weight is 2. An MCS 7845 can support a maximum of 10,000 units per server, but a maximum number of phones of 7,500, because you're always going to want some room for gateways and CTI route points, etc. Just a guideline. You're never going to have all the 10,000 units being taken up or consumed by phones. So the 7835 is 5,000 maximum device units, 2,500 is the maximum number of phones. The 7825 maximum device units is 2,000, maximum number of phones is 1,000. 7815, 400 and 200.